Hello my dear friends. So today once again we are going to talk something about aero engines, and today I will be talking about turbojet engine actually. Turbojet engines. Okay. So on this particular topic today I am going to talk, and that is turbojet engine. Today morning only I uploaded one video related to a general description of aero engines. Okay, so in that general description I described about some of the engines which are fitted on an aircraft. Okay, I discussed about turbojet engine, I discussed about turbofan engine, I discussed about turboshaft engine, I discussed about turboprop engine, and further I discussed about ramjet engine, I discussed about the scramjet engine. Okay, and given a small description I have given for you can say rocket engine also. Okay, so that rocket engine also I have described something, because all other engines are called as air breathing engine. Okay, so there is a clear differentiation between air breathing engine, air breathing and non-air breathing. You would have seen, actually this particular video is for those students who are studying aeronautical engineering, especially those who are studying aeronautical engineering or aerospace engineering. Engineering in various institutions. So for them actually it is very much useful. So now I am going to talk about turbojet engine. A brief description I will be giving you about turbojet engine. Okay, so let us see that what a turbojet engine actually. So to describe about an engine, as I told, that first of all we must know that what actually is an engine. So an engine is a device. What it is? It is a device which converts what? Energy. What it does? It converts energy from one form to another. Okay, so that is called an engine. So engine is a device which converts energy from one form to another. So we do have a heat engine. So if we are going for, then we can say that heat engine. So all engines which are fitted mostly on aircraft also, on automobiles also, on our two-wheeler also, on our four-wheeler also, buses, tractors, everywhere. So all these engines where fuel is burned first, then that fuel energy, or you can say chemical energy, is being converted to heat energy, and then heat energy is utilized to drive the crankshaft, and further that crankshaft is providing drive, and that drive is being transferred to the wheel. Okay, through some gear mechanism and other things. Those things I am not discussing about now. But what actually is it? Heat engine is also an engine which converts energy from one form to another, right? So that particular part is there. Even electrical motor is also an engine. So how it is an engine? Because electric motor, it converts electrical energy to mechanical energy. Okay, it converts electrical energy to mechanical energy. Similarly, we can say that a generator also is an engine because it converts mechanical energy to electrical energy. Okay, so understanding what's the difference? So why we are calling it an engine? So all engines converts energy from one form to another. Okay, right. So very nice. We discussed about an engine, what can be called an engine. So anything which converts energy from one form to another, that can be called as an engine. Okay, even the bicycle which we are riding, so muscular power is being converted to mechanical energy. muscular effort, right? Now, a simple description of turbojet engine only today I am going to discuss about, and in my next video I will be describing about other engines also in detail. So turbojet engine, a turbojet engine, so a general construction of a turbojet engine is in this fashion. Okay, a turbojet engine is enclosed in a duct, so this is called duct. Okay, a duct. Duct means a pipe through which something can flow from one place to another. Okay, now this duct will be consisting of a compression. Then further this compression is coupled with, you can say, a turbine, and here we do have combustion chambers all around this shaft. This is called compressor shaft. Compressor shaft and turbine shaft both are coupled together. Okay, so these act as one assembly. If turbine rotates, compressor also will rotate. So this is what? Turbine. And this is what? Compressor. And these are what? Combustion chamber. Right? And this is called compressor shaft. And further, this portion, it is called nozzle. This portion is called air intake. So now the parts of, so these things I will erase it now, it is not required. Okay, so the parts of a turbojet engine which is fitted generally in an aircraft and especially in fighter aircrafts. I have uploaded one video in which clearly I told that aircrafts are being classified on the basis of their role. So the first one is fighter, the second one is bomber, the third one is transport, the fourth one is for cargo, fifth one is for helicopter. So in this way, the aircrafts are being classified. Okay, so fighter aircrafts are fitted with the turbojet engine compulsorily because turbojet engines are the engines which can work beyond the speed of sound. Even at supersonic speed means you can say more than the speed of sound. Okay, so the speed of an aircraft actually it is measured in the form of Mach number. So Mach number is what? So you can say that the speed of object divided by speed of sound. So the Mach number is a dimensionless number which is speed of object by speed of sound. We can write it as V by A. And for your kind information, this speed of sound varies depending on the temperature. As we move up, as the height altitude is increasing, this is speed of sound. Okay, so what will happen? How we can write? So A is equal to whole root gamma RT. So as the temperature, because as altitude increases, temperature reduces. Okay, in the troposphere level, okay, when the altitude is increasing more and more from 1000 feet to 2000 feet, this temperature, atmospheric temperature keeps on decreasing. Due to this decrease in temperature, the speed of sound also decreases. Okay, so speed of sound is not a constant. Speed of sound is not constant. See, this gamma, which is the ratio of specific heats, R is the gas constant, which is constant, but T is not constant. So based on this formula, we calculate the speed of sound. Okay, right. So let us see that what a turbojet engine, what are the components. The turbojet engine is having, the very first component is air intake, through which air enters into the engine. So air intake. Okay, so the very purpose of air intake is to allow the air to enter in this particular duct in the engine assembly, and it is designed in such a way that it will be providing a smooth airflow. Okay, smooth airflow, and also reduce the speed of atmospheric air. So atmospheric air will be coming into this air intake with some speed. That speed also will be getting reduced. Okay, and it will provide, it's designed in such a way that it should provide a smooth airflow to the compression, because the compressor blade is designed to receive the airflow in particular fashion. Then only, so this compressor will be consisting of rotor and stator both. Okay, it will be consisting of rotor. Rotor means the disc which is rotating. So all around the disc, it is a circular disc, all around the disc blades are fitted, and the blades will be providing somewhere converging passage, somewhere diverging passage, or converging and diverging passage. Okay, so converging means what? When the area is reducing. Diverging means what? The inlet area is less, outlet area is more. Similarly, converging means what? Outlet area is more, inlet area is less. So squeezing action will be taking place. So the role of compressor is to squeeze the air, and thereby increasing the pressure. So the role of compressor is to increase the pressure. Okay, right. Now the pressurized air will be entering in the combustion chamber. Pressurized air at high pressure, it is entering in the combustion chamber. In the combustion chamber, injection of fuel will be taking place. That mechanism is separate. Okay, so fuel injection mechanism, that will be separated. So in this, high pressure air enters in the combustion chamber, and thereby fuel is injected, and there will be a mixing, vortex mixing will be there in the combustion chamber, and ignition also will be taking place through igniter plug. There will be an igniter plug. So ignition mechanism also, it is different. So ignition, it is a continuous ignition process. In this particular engine, it is a continuous ignition process. The role of combustion chamber is to provide a place for combustion of fuel and air mixture. Okay. So the air, from where it has come? It has come from atmosphere. That's why it is called air-breathing engine. Okay, whereas rocket, in which oxygen also has to be carried simultaneously, so that's why that is called non-air-breathing engine. Okay. So in the combustion chamber now fuel is burned, and as it is at high pressure, there is no pressure loss in the combustion chamber. It is assumed that there is no pressure loss, but actually some pressure loss is taking place, but as per theoretical, there is no pressure loss. The same high pressure air, when it is burned with fuel, so a high kinetic energy also being imparted to the air, high pressure air. So with kinetic energy, this high pressure air is moving out and hitting the blades of the turbine. Again in turbine, there will be a rotor blade, rotor disc will be there, there will be a stator disc also, it will be there, here also. Okay, rotor and stator both. Here also it will be there. The role of compressor is to squeeze the air, the role of turbine is to expand the air. Okay, so again during expansion process what happens? The pressure reduces, velocity increases. Whereas in squeezing action what happens? The velocity reduces, pressure increases. Okay, so the role of turbine is to expand the air. Expand the air. Air, now we cannot say that air because it has become gas. It has become gas. Why gas? Because fuel and air both are mixed together and fuel is burned. So now this air, the air which was up till here, air only it was there, that is being converted into gas. Okay, so now this gas, what is the purpose of turbine? Is to expand the air. By expanding the air, what happens? The pressure reduces, velocity increases. So it will be in several stages. You can say that if we want more power, the compressor also is built in more stages. So like twin spool compressor and all, and mini spool. Spools are the stages of compressor. So we can have multi-stages of compressor, and this particular part we can discuss later, no problem. So similarly, the turbine also will be of multi-stages. Okay, so in multi-stages, the work extraction is going on from turbine. So the turbine is extracting the work from that hot exhaust gases which is passing through it, and it starts rotating. The moment it starts rotating, as it is directly coupled with the compressor, so that compressor also starts rotating. Okay, so initially you will ask that initially what happens, sir, when there is no burning, when there is no combustion is taking place during starting of the engine? Yes, of course, you are very correct. So at that time what happens? By using starter generator, okay, by using electrical energy, or you can say electrical motor, which converts electrical energy to mechanical energy. So through gear drive mechanism, we will give drive to the compressor. So the compressor will start rotating slowly, and the air will get sucked in. The air will get sucked in. It is very much dangerous, gentlemen, for a turbojet engine. If it is running at high RPM, even the human being can also be sucked inside, and many disastrous accidents have already taken place. Okay, so one should be very careful while working near to this type of engine when it is running at full swing. Okay, so these are of different stages. So what actually I told, so during starting we use electric motor. We use electric motor, so we call it as starter generator. Why we call it as starter generator? So during initial it is we are providing electrical energy from battery, and then it will start rotating. Okay, so that electrical energy is converted to mechanical energy through gear drive. This compressor will be you can say rotated. Okay, so high pressure compressor is there, low pressure compressor is there, that is different. Okay, so this high pressure compressor will start rotating. Okay, and at certain RPM, now the air has passed through combustion chamber, fuel is injected, burning has taken place. So slowly this turbine will start rotating at higher speed. The more burning of fuel is taking place inside the combustion chamber. Then here also turbine will pick up the speed, and at a certain RPM, this starter generator which is coupled with this compressor, so its gear drive will be thrown out, will be thrown back. Thereby it will get disengaged. Okay, and the engine will start rotating at its own RPM. At its own RPM, and that starter generator, what we call starter, it will become generator. Then it will start producing electricity. Okay, that is also connected with one gearbox. Right, very nice. So you have understood now? Okay, so the air after expansion, it is at high velocity. Yes, it is at high velocity, and we do have two types of nozzle. One is called convergent nozzle, another one is called convergent divergent nozzle. So in normal, you can say with less power engine, we are utilizing as convergent nozzle. So the very purpose of convergent nozzle, what I said, inlet area is more, outlet area is less. So what happens? The velocity keeps on increasing here. So from this area, which is at a lower area, less area, from this place, when the gases are coming out, it will be at very high velocity. Okay, so this nozzle is designed in such a way, convergent nozzle. Convergent divergent nozzle is used in supersonic aircrafts. Okay, in supersonic aircrafts. So again here, that air will be moving out at very high velocity. So as I told you yesterday about Newton's third law, so the action, the hot exhaust gases are moving in this fashion. Okay, and this is the engine which is fitted on aircraft. So the action force is in this direction. Okay, towards the axis of the engine. This is called axis of the engine. Whereas reaction force is created, and this turbine structure will be forced forward, move forward. Okay, so that is the reaction force as per Newton's third law. Okay, so Newton's third law is utilized. Action force will be towards the back of the engine, whereas forward movement, forward force, reaction force will be created on the structure of the engine, and this structure of the engine is fitted on aircraft. So in turn, as a whole, because this whole engine is being pushed forward, so aircraft also is pushed forward. Okay, so that is there, as our hand is attached with our body. So if somebody is pulling our hand, our body also will be pulled together. So that is the reason here, this engine which is fitted on an aircraft structure, so aircraft also moves forward. Okay, so that is there, that Newton's third law. And this action of pushing the aircraft forward, pushing the engine forward, making it to make the aircraft move forward is called propulsion, and this is the force which is called thrust force. Which is called thrust force, gentlemen. Thrust. Okay, so this is the thrust which is produced and which is the main force which is making the aircraft to move forward. Thrust force. And this thrust force F is equal to rate of change of momentum, MA. Okay, MA, I am writing as MA. What it is, M dot, sorry, not MA. So F is equal to MA. We all are aware that mass into acceleration is the force. Okay, that only I am telling that the application of Newton's laws of motion. Okay, so F is equal to MA, and this MA we can write it as rate of change of mass flow rate of air into velocity. Okay, into velocity. So if suppose I am not writing this dot, so A can be written as B by T. Okay, very good. This can be written as M by T into V. Yes, of course. And M by T is written as M dot V. So F, so this is the thrust force, gentlemen. And M dot is nothing but rate of change of, so rate of mass flow rate of air. Actually it is what? Mass flow rate of air. So M dot V. Now this one I will erase it and I will write here. So F is equal to M dot V. V is the velocity, exit velocity. V is the exit velocity. Exit velocity means this one. Okay, so M dot A. So M dot A is the mass flow rate of air. Okay, so actually this particular thrust is called gross thrust. Is called gross thrust. Gross thrust. Now what happens once this complete structure, this engine structure is moving forward? Okay, so it will face some type of drag also with some velocity of air which is entering here. So it will be facing drag. Okay, so that drag force, that also we can write it as FD, drag force. So FD is equal to M dot A VA, and VA is the velocity of the aircraft or velocity of the air which is coming inside. Which is coming inside. So you can say that net thrust will be equal to, so this gross thrust minus this drag force. So M dot, or we can write it as net thrust Fn is equal to M dot Ve minus Va. So this is the explanation for thrust force actually. And what we have observed here, we have observed that this thrust force can be increased if we are in a position to increase the velocity of the hot exhaust gases through the nozzle. Okay, so either we have to increase the velocity of the exhaust gases or we can increase the mass flow rate of air. So this is the principle of that thrust. Okay, so the thrust, there is a need to increase more and more thrust if we want to increase the speed. So for that, what we need to do? We need to increase the mass flow rate of air. So a large capture, we have to capture a large mass flow rate of air which is applicable for propeller engines, where the engines are fitted with propeller turboprop engines, and another part we can increase the exhaust gas velocity. Okay, so in next class we will be describing more about on thrust when we will be describing about other engines also. So today I am stopping my you can say class about this turbojet engines here only, and if you have any doubt and all, then you can ask me, you can put comments. Okay, directly you can send mail to me also. I will reply you because it is my favorite subject. Okay, so right, very nice, and I will be coming back with the next video in which I will be describing about turbo shaft engine, I will be describing about turboprop engine, I will be describing about even ramjet, turbofan, okay, turboprop engine, all those engines separately I will be describing, and I will be telling you, I will be giving you clear picture of that. Okay, so right gentlemen, thank you.